Hello everyone, welcome to my channel. Today we shall see one of the most interesting and very important topic in database and most often overlooked topic in relational database. Now in my previous class I have shown you how to draw an ER model for a given application scenario. We consider the banking application, we looked at shopping cart, and we also looked at college database where we modeled the entities in using ER notations, namely entity, relationship type, cardinality ratio, etc. So today we shall see one of the most important topic in ER to relational mapping, where certain rules when you apply, we can translate an ER model into relational model. As we all know, relational model is the only thing that can be practically implemented, and most database management systems use relational model. So we need to first draw the ER model and properly verify whether everything is taken care of, and only after you get the complete ER model, we need to apply 7 mapping rules to get an ER model into a relational model. So let's get going. First, let's look at this ER model. This ER model is about shopping cart. Now, in this, we have certain very important entities that take part in this application. First and foremost is your customer entity. Then, when we have customer, he logs in, he looks at the product list. So, we have a product entity here. And from this product list, he will choose certain items to put them into cart. So, we have a cart entity. And once when he finishes entering all the items that he wants into the cart, he will click the confirm button, and whatever he confirms will be transferred into an order detail entity here. So as you can see, there are ordered items. So whatever we have in cart, they are all transferred to ordered items, and the summary of that will be in the ordered entity. So, and after the order is placed, the orders are shipped to the customer to the designated delivery address. So we can have more than one delivery address recorded from the customer, and whichever address he chooses, that is where the products will be delivered. So this is the complete application scenario. Now let's look at the details of this. Customer has customer ID, which is a key attribute, and we have all the details of the customer like customer name, cell number, his user ID, password. Of course, we have modeled the address as a separate entity, which is a weak entity, because one customer may have many addresses. So it is wiser to put that as a separate entity type and put its attributes like flat number, zip code, state, house number, street name, city, etc. So we have modeled the customer completely. In the cart, he has to place the items and he has to indicate how many quantities of that item are ordered and the unit price of it. We can derive the order amount once the items chosen are confirmed. So in the order items table, as you can see, there is a order item number, then item name, quantity, price, and the amount. Though this amount is, you need not store it, you can derive it. So what we can do is we can make it as a derived attribute. So you need not store that in the model. Then we have order, which keeps a summary of the items order, that is order number, order date, then how much is the total order amount, and what is the order status, whether the order is pending or dispatched or it is delivered. So we have various values for this order status. Okay, and in the product table we have the product ID, product name, price, and etc. Now this is very good tool to understand the different data items that are there in the shopping cart application, but this is no good if you want to store the data in a database. Most databases today use relational model, and in relational model all these have to be translated into tables. So how do I map each of these entities into relation? So let's look at the details of how to map the ER model to relational model. So in this we have 7 mapping rules. So let's look at each one of them. The first rule, what it says is for every strong entity in ER model, create a new relation with all simple attributes included. And if there are any composite attributes, the subparts of that should be included as attributes in the new relation. Now, for instance, if you look at the diagram here, which are the strong entity type? Customer is a strong entity type, order is a strong entity type, order items, products. So these are the 4 strong entity types. For each of them, I need to create a table here. So let's create a customer table. So first one is your customer. So to create table, I would better use a square block here. So what are the important simple attributes? The customer ID, which is a key attribute, which becomes a primary key here. Customer name, cell number, then user ID, password. Maybe you can put gender as one other attribute. You can go on adding. So these are all simple attributes of customer. Similarly, we have product. So we have product ID, which is a key attribute, product name, unit price, then size, discount, whatever. So whatever attributes that are included in the product entity, we have to include like that. So now if you look at other entities, we have order and order items. So if you look at order, what are the simple attribute? Order ID, which is a key attribute, order date, order amount, and you can include status. Then order details, that is another relation. So this is also a strong entity type. You include all the simple attributes of this. So here you would include order ID and order item together as the key. Then you will have quantity, unit price, amount you can derive, or if you want you can include that so that you don't have to calculate it every time. So when you apply first mapping rule, we will get all the tables related to strong entity type. The second mapping rule says for every weak entity type, create a new relation by including all its simple attributes and also include the owner entity key as part of primary key of this new relation. Now, just to illustrate what is the meaning of this mapping rule, we know we have delivery address as the weak entity type. So in this, what is the owner entity type key? It is the customer ID. Then delivery address is the address, is a partial key. Together they form the key. And then here we can have flat number, house or apartment number, city, and zip code. So these are the attributes that form the weak entity type. So if there is any other weak entity type, you can include, especially the cart, you can have a relation like that. So cart should also be converted into a relational model using the second rule. So what all we have in the cart? We have the item number. So along with item number, you must include customer ID and the item number. Together they form the key. Then we have quantity, unit price. Then you can include amount, or you can skip that. So these are the two relations that result because of second mapping rule. What about the third mapping? Now, third mapping rule is applicable to entities which are participating into 1:1 relation. So for every 1:1 relation, identify the entity that is fully participating in the relation, and include the key of partial entity as foreign key. Okay. Now I don't have a one is to one relationship in my ER model. If you consider the employee and department, so we know that department is fully participating in the managers relation. So every department will have a manager. So if I take department here, assume that department is already mapped to a relation. So we have department number, department name, then budget, etc. And this is the key, and all employees will be participating in this, but uh, every department will have a manager. So manager will be identified by his social security number. So you can include MGR SSN as the foreign key in this table, and this refers to the employee SSN on the employee side. That is because every department will have a manager. So this entity is fully participating in it. And it is a one is to one kind of a relationship. So third mapping rule applies to uh, one is to one. The fourth mapping rule is for one is to n. So we have to identify those relationships which are of type. If you look at this diagram, there is customer and order, which is one is to n. Okay. So to know who has ordered the items, okay, or to whom this order belongs to, the customer CID should be foreign key in the order. So what this rule says is, on the n side you put the key attribute of the one side. Okay, so let me list out what this rule says. What it says is, for every one is to n relation, include on n side the key attribute of one side as foreign key. Okay, so when I do that, we have already created the order table. If I go up here in the order table, we have to include as foreign key the primary key of the customer, that is CID. Now what is the use of putting this as a foreign key? So as you can see, this is the only means of identifying to whom this order belongs to. Without this, the order has no meaning, because order cannot just come like that. It has to come from the customer. So putting a customer ID tells you that this order belongs to a particular customer. Okay, so for every 1 is to n, you have to do that. Same thing has been already done here. Order details is a weak entity type. As you can see, this is a foreign key here pointing to this. So for every 1 is to n, you must do that. Now coming to fifth rule, for every m is to n relation, create a new table with key attributes of both sides as primary key, and include any attributes of the relation itself. Any attributes of the relation. A relation can also have attributes. Now we don't have m is to n in this shopping cart. I will give one example where we have employees and we have projects here, and the relationship is works for or works on, and depending on how many hours each employee works, there will be hours attribute, and this is of the time m is to n, because many will be working on a single project, and one employee will be working on many projects, and on one project there are many people. So this is a m is to n kind of a thing. So what you have to do for this thing is, you have to create a new relation works on, Okay, so I'll just draw it neatly. So we have a relation works on. So what are the attributes of this new table? It is simply the key attributes of the participating entity type. So we have employee ID here. On the project side, we have a project ID, project number. So employee ID, project number should be included, and these two together form the primary key. Okay, and as you can see, this relation has the hours as the attribute, and you must simply include it here. So all m is to n relationships have to be converted into a new table like this. Okay, now rule number 6 is for n-ary relationships. Now normally this is very rare, but if I have one, if you have more than three entities participating, for example, in a project, there could be supplier and item taking part. So supplier ID, project number, and item number. So these together and how much quantity of that is utilized can be. And as you can see, all these three will be part of the primary key. So it is very rare to have any relationship. If at all you have one, this is how you have to map. All right. So the seventh rule is for every multi-valued attribute, you must create a new relation and include the multi-valued attribute and the key attribute of the relation as primary key. So suppose department has many locations. So you would write department location as a new relation, the location. So department number, department location. Okay, so these are the only two attributes that come. Okay, so if you wish, you can add something more. For example, uh, distance. So whatever is that location, how far is it from the main office? So this kind of a, and these two together will form the key of the new relation. Okay. So to summarize, we have 7 mapping rules. After drawing the ER model, you have to consider all the entities which are participating, all the relationships which are participating, and all the attributes of the entities which are there in your ER model. And there are 7 mapping rules. So first mapping rule is for strong entity types. Second is for weak entity types. Third one is for 1 is to 1 relation. Fourth one is for 1 is to n relation or n is to 1 relation. Fifth one is for m is to n relation. Sixth one is for n-ary relationship. And seventh one is for any multi-valued attribute that might be present in your ER model. So only after applying all these rules, you will have all the relations in place. The next logical step would be to verify whether all these relations are in certain normal form. But in most cases, after you have converted into relational model, most of the relations will be already in third of normal. So this is a very, very important topic in databases where you must develop the expertise, keeping in mind all the 7 rules to be able to convert the given ER model into relational model. I hope you all like this video, and if you like the video, click on the bell icon and subscribe to my channel. Thank you.